This is about as far as we got last time. The average rate of change between 2 points on a graph is equal to the slope of a line connecting those 2 points on the graph. This is what's called a secant line. You learn more about that in calculus. Yeah, we're recording. We're live. Yeah. Thanks for reminding me though. Yeah. So anyway, to find the slope of that line between the 2 points, you use the slope formula. Change in y divided by change in x, or f of x2 minus f of x1 all over x2 minus x1. So your homework starts off, I only assigned like 10 problems from this section because they're all pretty easy. The first ones actually give you a graph with a line through it already, and they ask you for the average rate of change between those 2 points. So how do you find that? You could find the equation of the graph, but all you need is the slope of that line, right? So you could just count the rise over the run and divide it. Am I making sense here? So those first couple of problems on your homework can be really easy. Just count the rise over run, make it into a fraction. That's the average rate of change. Okay. So I'm going to skip examples like that because they're pretty easy. Let's go to example 1. Find the average rate of change. Hey, camera. So here's your equation. Y equals 4x minus 2. I want you to find the average rate of change for x equals negative 4 and x equals positive 1. To find the average rate of change, you have to have 2 points on the graph to calculate the rate of change between. So this actually should be fairly obvious without even using this equation. This is the formula you're supposed to use to find average rate of change, because we've been given 2 points. We can call this one x1, we can call that one x2. But just by looking at the equation, we know immediately the average rate of change between any 2 points on this graph. Why is that? What type of graph is this? This is linear. So between any 2 points on the graph, at anywhere on the graph, the slope's always going to be the same. What is it? Because this line has a slope of 4, that is the average rate of change. That's just because this is a linear function. But for the sake of practice, let's just practice the formula, just so we can get it down. Let's do f of x2 minus f of x1 all over x2 minus x1, even though we're sure what should this equal when we're done with this? 4. It should equal 4, because that's the slope of this line. But let's double check. So if x2 is equal to 1, we need to find f of x2, and we also need to find f of x1. Then we need to subtract those 2 quantities. So f of x2. What is f of x2?
4 minus 2.
Yeah. F of x2 is the same as f of 1, because x2 equals 1. F of 1 is 4 times 1, which is 4 minus 2, so that's 2. F of x2 equals 2. x1 is equal to negative 4, so we need to find f of negative 4. 4 times negative 4, negative 16 minus 2 is negative 18. Okay. So what we need to do now is plug this in. F of x2 was 2, and then we minus negative 18. And then x2 minus x1 is 1 minus negative 4. You guys, the biggest mistake that I see on these types of problems is not conceptual understanding, it's arithmetic mistakes. You guys got to be careful with your arithmetic. 2 minus negative 18 is 20. 1 minus negative 4 is 5. 20 divided by 5 is 4. The average rate of change of that graph is equal to 4, but that should have been fairly obvious because this is a linear function with a slope of 4. So let's do a little more complicated one. F of x equals negative 2x squared minus 4x. And I want you to use these two x values. x1 equals 2, x2 equals 5. So it's the same formula. F of x2 minus f of x1 all over x2 minus x1. Go ahead and give it a go. I'll let you work on this one. Well, what did we get? So I heard a negative 18. Is that what you got? Negative 18? Only 2 people? You got negative 18? Well, let's see. F of x2 is the same as f of 5. So 5 squared is 25 times negative 2, that's negative 50. Negative 4 times 5 is minus 20. So that's negative 70. F of x1 is equal to f of 2. 2 squared is 4 times 2 is negative 8. Negative, that's minus 8, so that's negative 16. So we have negative 70 minus negative 16 all over 5 minus 2. Negative 70 minus negative 16, oh boy. Negative 54 divided by 3. Now, you guys, remember, I can't control what you're doing during lessons and during homework, but on exams, this is a no calculator problem. Okay? So you've got to become very meticulous in your work and very careful. Negative 54 divided by 3 is negative 18. So the average rate of change is negative 18. And that's the average rate of change. Now, again, just keep this in perspective. What's the point of learning this? This is a preparatory discussion for calculus next year. Okay? And just to give you a heads up of what's coming, it's kind of hard to manipulate this graph. It doesn't really move. But imagine this, you guys. If I were to take this point, are you guys all watching? If I were to take this point and start to drag it down along the parabola, so let's say I took this point that's in red and drug it down to here. Now does this line have the same slope? No, it'd have a little bit of a different slope. This point didn't change, but now it looks like that. What if I kept dragging it closer and closer to this line and closer to that point until eventually, what's that called as a tangent line? We started with a line between 2 points, a secant line. In calculus, you deal more with what are called tangent lines. The tangent line, the slope of the tangent line is what is known as a derivative. So you're going to learn a lot about derivatives. And this is the basics of the beginning of a derivative. Anyway, that's what it is. Let's move on to 2.5. So new lesson, start a new note.